Hi everyone. Hi everyone. Welcome back. On today's series, we are going to see about the condition for maximum torque of an three-phase induction motor. So, already in previous section itself, we've seen the torque equation of three-phase induction motor and how the torque is developed inside the induction machine. So from this torque equation, we are clearly understand the torque is mainly depends on only the slip, because the other parameters like the supply voltage, the supply voltages we are always maintaining as constant, and also the ratio between the induced voltage from the stator to rotor is also a constant. Then similarly, the rotor resistance, rotor reactance, and the synchronous speed, everything is constant in an induction motor. So from this, the torque is only depends on the slip. The slip is changes when the load, when the speed. If you are changing the load of three-phase induction machine, the load is changes, the speed will change. If the speed is changes, the slip will change. So the torque produced inside the machine is mainly proportional. It is mainly depends on the slip. So mathematically, for obtaining the maximum torque, so we can differentiate the torque equation with respect to the slip. So dt by ds, which is equal to 0. So where the torque is, already we are derived the torque of the induction machine T is equal to constant K into slip S into E2 square R2 divided by R2 square plus S into X2 whole square. Now we have to differentiate this torque equation with respect to slip. Okay. Here, so now you can see we have to differentiate the torque. We have to differentiate the torque equation. You can see the numerator as well as the denominator. In both numerator section, as well as denominator section, the S it contains. So here we have to differentiate with respect to S only, because it is on slip. Because the slip is an only variable in the torque. The torque is mainly depends on the slip. So it has both numerator as well as denominator. So definitely we have to apply the U by V formula. So which is called, so U into dV, that is V du. Okay, that is called V du minus U into dV divided by the V square. So this is the differentiation formula based on the U by V. So we have to differentiate the torque equation with respect to S, and which is equal to 0. So first of all, the denominator for V. So okay, so first U dV, U into dV. So this is called U and this is called V. So from this that is U into dV. So we have to keep the numerator part U as it is, and the denominator should be differentiated. So in denominator R2 square plus S square into X2 square. So we have to differentiate this one, and minus V into du. So we have to keep the V as it is, and we have to differentiate the U, that is numerator part, and divided by V square divided by the denominator is already V. So the denominator should be squaring. So that is called V square. That is we have to put the whole square. So this is a formula of differentiation based on the U by V. So next, so by taking the U by D by formula, finally we are getting this is the answer, and here while we are multiplying each other, we are getting the final equation this, and from this finally we are getting we are by cancelling those things, and we are taking the K into E2 square R2 square common, and if you are taking that from the left hand side to the right hand side, it will gets multiplied. So finally we are getting the value S square X2 square minus R2 square, which is equal to 0. So the R2 square can be taken from the left side into right side. So therefore S square X2 square, which is equal to R2 square, and S2 square is equal to R2 square divided by X2 square. And if I am in need of only the slip, So by taking the root, so S is equal to R2 by X2. So the slip is mainly depends on, here the slip is mainly depends on, it is based on the rotor resistance and rotor reactance. It is the ratio between the rotor resistance and rotor reactance. Okay, so the maximum slip, the slip at which the maximum torque is, which is R2 by X2. Okay, so it is the ratio between the standstill conditions. So this is the magnitude of maximum current. So the Sm is equal to R2 by X2. This can be substituted in the torque equation, and we can, while simplifying, we are getting the maximum torque of magnitude is equal to K2 into E2 square divided by 2 into X2 Newton meter. Okay. So this is an assessment. The maximum torque is depends on which parameter, whether rotor reactance or induced EMF at standstill condition or the rotor resistance. So put your answer in the comment section. And these are the few references for this topic. Thank you.